Hello everyone, welcome to lecture 8 of CRN 603, and in this lecture we shall be looking at user interface design when dealing with developing a new system, and also how we go around designing an interface in the systems design phase of the SDLC. The objectives of this lecture are explain the concept of user interface design and human-computer interaction, including basic principles of user-centered design, explain how experienced interface designers perform their tasks, describe rules for successful interface design, discuss input and output technologies. Moreover, design effective source documents and forms, explain printed output guidelines, describe output and input controls and security, and finally, explain modular design and prototyping techniques. System design phase overview. The goal of the system design phase is to build a system that is effective, reliable, and maintainable. Our system is effective if it supports business requirements and meets user needs. Our system is reliable if it handles input errors, processing errors, hardware failures, or human mistakes. Moreover, our system is maintainable if it is flexible, scalable, and easily modified. System design phase overview continued. Will it succeed? Suggestions for successful design. First of all, we need to think like a user. Carefully examine any point where users provide input or receive output. For a system to be successful, we need to anticipate future needs and provide flexibility. In other words, the system needs to be scalable. It needs to anticipate possible expansion and offer several alternatives. And finally, for a system to be successful, it needs to manage data effectively. Now, system should enter and verify data as soon as possible. Input data must be close to its source, and a secure system must include audit trails. Overview. Users can design their own output. That is, system designers are more aware of the user's needs and desires. Centralized IT departments no longer produce reams of printed reports. Customer design output is the current trend. The user interface has evolved. That is, most user information needs can be met with screen-generated data. Moreover, it continues to evolve with the use of mobile and wearable devices. What is an interface? An interface describes how users interact with the computer system. Moreover, it comprises features that affect two-way communication between the user and the computer, whereby the user initiates the communication and the computer corresponds. Now, central to usability is the user interface. In other words, in a user-centered system, the distinction blurs between input, output, and interface itself. What is a user interface? User interface has been derived from the concept of human-computer interaction. HCI describes the relationship between computers and people who use them to perform their jobs. Early user interfaces had complex commands and very few graphical user interface. Transparent user interface does not distract the user. Moreover, the objective is to create a friendly user design that is easy to learn and use. Let's go and have a look at the 7 habits of a successful interface design. Habit number 1, understand the business. The interface designer must understand the underlying business functions and how the system supports individuals, departmental, and enterprise goals. Moreover, should maximize graphical effectiveness. A well-designed interface enables repeat learning. Should think like a user. The designer must see the system from a user's perspective. Use models and prototypes. Designers can present initial screen designs to users in the form of a storyboard. Users should test the design and provide feedback. Focus on usability. Include main options in the opening screens. Offer a reasonable number of choices that a user easily can comprehend. Moreover, invite feedback. Monitor system users and solicit user suggestions. Determine if system features are being used as intended by observing and surveying users. Another useful habit for interface designers would be to document everything. Document all screen designs for later use by programmers. User-approved sketches and storyboard can be used to document the user interface. And finally, create an interface that is easy to learn and use. Focus on the system design objectives. Create a design that is easy to understand and remember. Provide commands, actions, and system responses that are consistent and predictable. Allow users to correct errors easily. Clearly label all controls, buttons, and icons. Guidelines for user interface. The very first guideline that we're going to look at is create an interface that is easy to learn and use. Is to select familiar images and users, to select familiar images that users can understand. Provide on-screen instructions that are logical, concise, and clear. Show all commands in a list of menu items. Dim any commands that are not available to the user. Make it easy to navigate or return to any level in the menu structure. The next guideline is enhance user productivity. To enhance user productivity, the following requirements need to be met. Organize tasks, commands, and functions in groups that resemble actual business operations. Create alphabetical menu lists or place the selections used frequently at the top of the menu list. Provide shortcuts for experienced users. Use default values if the majority of the values in a field are the same. Use a duplicate value function, but allow users to turn this feature on or off as they prefer. Provide a fast find feature, and moreover, if available, consider a natural language feature that allows users to type commands or requests in normal text phrases. The next guideline for user interface design is provide users with help and feedback, and the following needs to be met. Ensure that help is always available on demand. Provide user-selected help and context-sensitive help. Provide a direct route for users to return to the point from where help was requested. Include contact information. Provide users with help and feedback continued. Require user confirmation before data deletion. Provide an undo key. When a user entered command contains an error, highlight the erroneous part. Use hypertext links to assist users. Display messages at a logical place on the screen. Alert users to lengthy processing times or delays. Allow messages to remain on the screen long enough for users to read them. Let the user know whether the task or operation was successful or not. Provide a text explanation for an icon or image on a control button. Use messages that are specific, understandable, and professional. The next guideline for a successful user interface design is create an attractive layout and design. The following elements need to be met. Use appropriate colors to highlight different areas of the screen. Use special effects sparingly. Use hyperlinks that allow users to navigate to related topics. Group related objects and information. Display titles, messages, and instructions in a consistent manner. Ensure that commands and similar mouse actions will have the same effect. Require the user to confirm the entry by pressing Enter or Tab. Remember that users are accustomed to a pattern of red, stop, yellow as caution, and green as go. Provide a keystroke alternative for each menu command. Avoid complex terms and technical jargons. The next guideline for a successful interface design is enhance the interface, and the following needs to be met. Opening screen is important as it introduces the application. The starting point can be a switchboard with well-placed command buttons for navigation. Use a command button to initiate an action. Try to create customized menu bars and toolbars. Add a shortcut feature that lets a user select a command menu. If variable input data is needed, provide a dialog box that explains what is required. A toggle button makes it easy to show on or off status. Use list boxes that display the available choices. Use an option button or a radio button to control user choices. If checkboxes are used to select one or more choices from a group, show the choices with a check mark or an X. When dates must be entered, use calendar controls. The next guideline for a successful user interface design is to focus on data entry screens. Use the form filling method whenever possible. Restrict user access to screen locations where data is entered. Provide a way to leave the data entry screen at any time without entering the current record. Provide a descriptive caption for each and every field. Provide a means for users to move among fields on the form in a standard order or in any order they choose. Allow users to add, change, delete, and view records. Design the screen form layout to match the layout of the source document. Display a sample format like month, date, or year, or you may also use day, month, or year, and use an input mask. Require an end stroking for every field. Do not require users to type leading zeros for numeric fields or trailing zeros for decimals. Display default values. Provide users with an opportunity to confirm the accuracy of input data before displaying it. Guidelines for successful user interface design continued. The next guideline is to use validation rules. There are a few types of validation checks and controls that could be catered for when dealing with validation rules. Let's go and discuss them. Sequence check, used when the data must be in some predetermined sequence. Existence check applies to mandatory data items. Data type check tests to ensure that a data item fits the required data type. Range check used to verify the data item fall between a specified minimum and maximum value. Reasonableness check identifies values that are questionable but not necessarily wrong. Validity check used for data items that must have certain values. Combination check performed on two or more fields to ensure that they are consistent or reasonable when considered together. Batch controls, totals used to verify batch input. The next guideline for a successful user interface is reduce input volume. And these are the requirements that must be met. Input necessary data only. Do not input data that the user can retrieve from system files or calculate from other data. Do not input constant data and use codes as they are shorter than the data they represent. Source document and form design. First concept is garbage in and garbage out, or GIGO. Quality of input that basically depends, quality of output that basically depends on the quality of input that is set in by the user. Source document. A source document collects input data, triggers an input action, and provides a record of the original transaction. A good form layout makes the form easy to complete and provides enough space. Information should flow on a form from left to right and top to bottom. Printed output. Questions that needs to be taken into consideration before designing a printed output. Why is this being delivered as printed output? Who wants the information? Why is it needed, and how it will be used? What specific information will be included? Will the printed output be designed for a specific device? Do security or confidentiality issues exist? Printed output continued. Overview of report design. Organizations strive to reduce the flow of paper and printed reports. Users find it handy to view screen output, then print the information they need. Printed output is used in turnaround documents. Reports must be easy to read and well organized. Database programs such as Microsoft Access include a variety of report design tools to create reports quickly and easily. Types of reports. Some common types of report in printed outputs include detailed reports. Produce one or more lines of each record processed. It is usually quite lengthy. Exception report. Displays only those records that meet specific conditions, and it is useful when user would like to extract only specific information from a list of data. Summary. Reports that provide comprehensive data. In printed output, we also have a concept of user involvement. User involvement, basically whereby users must approve all report designs in advance. A mock-up or a prototype can be prepared for the users to review. Report design principles. Every report should have a report header and a report footer. Our report header identifies the report and contains the report title and other necessary information. Report footer contains end of the report information. Report design principles. Report header and footer. Report header includes the column headings that identify the data. Report footer displays the report title and the page number. Repeating fields. It is user's opinion that helps provide clarity. Consistent design. It is the look and the feel that are important to users, so reports should be uniform and consistent in design. Output technology and technological issues. Actual forms, reports, and documents have to be created to be accessible from workstations, notebooks, tablets, smartphones, and other devices. And it must also cater for internet-based information delivery. Moreover, it should allow users to download a universe of files and documents to support their information needs. Companies use a live or pre-recorded webcast to reach to prospective customers and investors. Therefore, in the output technology issues faced is that in addition to screen output and printed matter, output can be delivered in many ways. Actual forms, reports, and document or internet-based information delivery are catered for. To display output or forms or reports in these mediums becomes often very, very comprehensive and moreover becomes very difficult to lay it out to the users in a correct manner. Moreover, looking at output technology, we also have emails. Emails are generally an essential means of internal and external business communication. Blogs, web-based blogs, useful for posting reviews or news, reviewing current events, and promoting products. Instant messaging or IM, useful for team members in a collaborative situation. Wireless devices. Data can be transmitted using the internet across a wide array of devices. Other output technologies also include digital audio, image, and video. Can be captured and stored in a digital format, can be attached to an email message or inserted as a clip in a Microsoft Word document. Podcasts, used as sales and marketing tools and to communicate with employees. Automated facsimile or fax back systems allow a customer to request a fax using email via the company website or by telephone. Computer output to microfilm, COM, used by large firms to scan and store images of original documents to provide high-quality record management and archiving. Computer output to digital media, used when many paper documents must be scanned and stored in digital format for quick retrieval. Specialized forms of output, portable web-connected devices that can run multiple apps, retail point-of-sale terminals that handle credit card transactions, automatic teller machines or ATMs that can process bank transactions, special purpose printers. We also have plotters that can produce high-quality images, electronic detection of data embedded in credit cards, bank cards, and employee identification cards. Input technology. So the input technology has evolved over the years. From using a keyboard, now we end up using a BCI, which is a brain-computer interface. Students are requested to go through this table to adjust and to know of the traditional, evolving, and emerging input technologies. Input technology. To input data, basically it happens in two modes, either in batch or online data entry. When talking about batch input, data entry is performed on a specified time schedule, such as daily, weekly, monthly, or on longer times. Online data entry enables immediate validation and availability of data. That is, data is entered at the very same time. Source data automation combines online data entry and automated data capture using input devices such as RFID tags, magnetic data strips, or smartphones. It becomes fast, accurate, and minimizes unnecessary errors. Examples of source data automation are point-of-sale terminals. These are equipped with barcode scanners and magnetic swipe scanners. Automatic teller machines can read strips on bank cards. Factory employees use magnetic ID cards to clock on and off specific jobs. Hospitals imprint barcodes on patient identification. Bracelets and use of portable scanners when gathering data on patient treatment and medication. Retail stores use portable barcode scanners and libraries use handheld scanners. Trade-offs. Trade-offs are manual data entry, and it is slower and more expensive than batch input. Decision to use batch or online input depends on business requirements. Security and control issues. Companies use output control methods to maintain output integrity and security. Output security protects privacy rights, shields the organization's proprietary data from theft or unauthorized access. Security solutions is provided into two forms: diskless workstations, network terminals that supports a full-featured user interface but limits the printing or copying of data. Port protector controls access to and from workstation interfaces. Input security and control continued. Input control ensures that input data is correct, complete, and secure. Information should be traceable back to the input data that produced it. Procedures must be put in place for handling source documents to ensure the data is not lost before it enters the system. Data security policies and procedures protect data from loss or damage. Companies should have a records retention policy that meets all legal requirements and business needs. Audit trail files and reports should be stored and saved. Where do we go from here in terms of user interfaces? Modular design. Individual components called modules connect to a higher level program or process. It is designed to perform a single function. In a structured design, each module represents a specific process shown on a data flow diagram and documented in a process description. Prototyping involves a repetitive sequence of analysis, design, modeling, and testing. System prototyping produces a full-featured working model of the information system. Prototyping. Let's look at some of the benefits of prototyping. Users and system developers can avoid misunderstandings. System developers can create accurate specifications for the finished system based on the prototype. Managers can evaluate a working model more effectively than a paper specification. Helps in developing testing and training procedures. Reduces the risks and potential financial exposure that occur when a finished system fails to support business needs. Some potential problems related to prototyping include rapid pace of development can create quality problems, which may not be delivered until the finished system is operational. System requirements such as reliability and maintainability cannot be tested adequately using a prototype. In complex systems, the prototype can become unwieldy and difficult to manage. Clients may want to adapt the prototype with few to no changes, leading to increased maintenance costs later in the SDLC phase. Lecture summary. Purpose of the system design is to create a physical model of the system that specifies or satisfies the system design, satisfies the design requirements that were defined during the system analysis phase. User interface design must be based on the perspective of the user. Types of printed reports include detailed, exception, and summary reports. Various zones in a document include heading zone, control zone, instruction zone, body zone, total zone, and authorized zone. Input methods include data capture and data entry. Security and controls play an important role in the designing of an interface. This summarizes and this finishes up with the lecture 8 of CRN 603. Thank you for listening, everyone.